Life is a mysterious thing. As far as we are currently aware, Earth is the only place in the universe where it exists. While this might make us feel quite unique, it's also a little disconcerting. Humans are social creatures, and we often don't really like the idea of being completely alone. So it's no wonder, as the years went by, that humanity has cast its gaze out across the wider solar system in search of life. Although we have realized by now that life is not obviously in our solar system, there are no other lush, green planets here except our own, that doesn't mean the search has ended. You might be surprised just how many locations in the solar system still harbor rocks that need to be unturned. We may not need to fly to distant planetary systems to find life. Life might still exist in our own celestial backyard. I'm Alex McColgan, and you're listening to the Astrum podcast, and together we will travel through the solar system and see where the most likely places to find life could be. Let's begin by informing our search, by reminding ourselves of two of the main factors needed for life. It's almost certain that one such factor is liquid water. Liquid water is essential because biochemical reactions can take place in water. Water is also an excellent solvent that easily dissolves and carries nutrients and other compounds in and out of cells. Water is so important that all life forms on Earth are made primarily of water. For instance, our human bodies are more than 60% water. So, locations scientists expect to find life in the solar system are places with water, and that are not so cold or so hot that liquid water can't form. Secondly, life almost certainly requires an energy source to power its growth, its chemical processes and reproduction. Interestingly, this does not necessarily need to come from the sun. Previously, scientists believed that the sun was the source of all energy for life on Earth, but as we explored the bottom of our own oceans, we found ecosystems that were completely independent from the sun. The organisms there relied on chemicals and energy released by hydrothermal vents. Bacteria there use chemosynthesis, not photosynthesis, to create energy for themselves. These bacteria coat the vent, where amphipods and copepods graze on them directly. Above them in the food chain are snails, shrimps, crabs, fish, eels, and a host more. Here the temperature is hot and the pressure is enormous. So, if something similar to hydrothermal vents exists in locations around the solar system, and life isn't unique to only Earth, they would be as good a place as any to look for life. So, with those two factors in mind, let's begin our search. Let's begin with our Sun. It is a very nice and stable type of star known as a G-type main sequence star. Not a good place to look for life as far as we know though. Certainly nothing like life on Earth could survive the thousands of degrees temperature on the surface. We would have to expand our concepts of what life could be. Perhaps beings of energy rather than traditional elements. Neil deGrasse Tyson said he wasn't opposed to the idea. However, the possibility is extremely remote. So I think we can leave the Sun and move on to Mercury. Mercury does not tick many boxes in regards to what would be needed for life to form. It has a very tenuous atmosphere and is far too close to the Sun. This combination means that temperatures on the day side rise to over 400 degrees Celsius, and the night side can drop as low as minus 170 Celsius. It has been discovered that Mercury was geologically active in the past, but the last eruption was thought to be 1 billion years ago. Many extinction events would have happened during Mercury's history that would, most likely, have prevented life from getting anywhere. There is water ice to be found in the permanently dark craters around the planet's poles, but we theorize that only liquid water can support life. Mercury seems to be a dead, inactive, and sterile planet. The next place to visit is Venus. Venus does have a rather substantial atmosphere, but the problem is that it still isn't quite far enough away from the Sun to be in the Goldilocks zone. On Venus's surface, it is even hotter than Mercury, well over 400 degrees Celsius all over the planet. This is due to the greenhouse gases in the atmosphere, carbon dioxide making up 96% of it. This means that water could not stay in liquid form on the surface. You might be tempted to pass Venus over as a home for life, but there is a slight possibility that there could be some form of microorganisms high in the clouds of Venus that could use UV light from the sun as an energy source. The reason scientists believe this is because in 2020, phosphine was detected in Venus's atmosphere. Although phosphine can come from a number of sources in nature, one of them is by microbial life. Besides, the temperature and high pressure in the atmosphere is much more hospitable than on the surface, so this possibility exists. Moving on, one of the best bets in the solar system is Mars. It is situated nicely in the Goldilocks zone and has an atmosphere. The big problem with Mars, though, is the lack of a magnetic field. The magnetic field on Earth prevents the solar wind from the sun stripping away the particles in the upper atmosphere. Because Mars doesn't have this, its atmosphere has been stripped of all but the heaviest molecules, consisting of 96% carbon dioxide. At one point in its history, it did have surface water, as can be evidenced by dried up rivers and lake beds. However, today that water has gone, and if there was any life on the surface, this has most likely gone too. Scientists have been keen to find evidence in rocks with the Viking missions, and looking for methane in the atmosphere with the rovers currently on the planet, but they have so far only found traces of evidence. But NASA are not deterred. Finding solid evidence of life on Mars is now one of their primary objectives, so they clearly think there is still a good chance of finding something. There are a few telltale signs that life could have existed or still does on Mars. There are possible biosignatures, like methane in the atmosphere, often the byproduct of life. Scientists can't quite agree on where the quantity of methane gas comes from, and life is a definite possibility. We also have 34 meteorites which originated from Mars. These are highly valuable, as they are the only samples from Mars that we possess. A few of these meteorites even contain what looks to be fossilized bacteria, although they are much smaller formations than any terrestrial bacteria on Earth. This is not conclusive evidence, however, as even these formations can be explained by natural processes. At this point in time, there are a couple of possible places to find life on Mars. One would be about 10 meters under the surface. Water can be found in liquid form this far down, and any life would be much more protected from cosmic and UV radiation. Another theory is that microorganisms could exist under the polar ice caps. Potential evidence of this could be the darkening of these spider patterns next to the geysers on the poles. With all the attention Mars is getting from the global scientific community, I would guess we will know conclusively whether there is life on Mars within the next 30 years. The first planet after Mars is Jupiter. Jupiter itself is not at all hospitable to life as we know it. It barely has any form of water, it doesn't have a solid surface, and the winds and convection forces on the planet would drag down any microorganism that tries to form in the tops of the cloud layer. The deeper you go into Jupiter, the more the pressure and heat increases. The chances are very slim that life could exist here in these extremes. However, Jupiter has some moons where the conditions are much better. The biggest of Jupiter's moons, called the Galilean moons, are big enough to have differentiated interiors. Small moons and asteroids tend to just be the same throughout, like a rock. However, bigger moons will often have layers and cores. The second of Jupiter's Galilean moons, Europa, is actually one of the most likely places to find life in the whole solar system, but not on its surface. The crust of Europa looks extremely unusual with these fault lines running all over. This is because the crust is actually made of water ice, and underneath this ice sheet is believed to be a liquid water ocean that spans the entire moon. Evidence of this can be seen through rotation of the crust, which is thought to have moved by up to 80 degrees. Very unlikely to have happened if the crust and core were solidly attached. Another piece of evidence is something that has only just been confirmed in the old Galileo spacecraft data. Galileo actually detected water plumes or geysers shooting water far into space when it passed by the moon very closely. In 2016, the Hubble team suspected they might have imaged water plumes shooting 200 kilometers into space, and this rediscovered Galileo data has confirmed it. NASA considers the prospect of life here so intriguing that there will be a dedicated Europa Clipper mission due to be launched in October 2024. The Europa Clipper will orbit Europa, passing through the water plumes, sampling the water that is ejected. We're not expecting to find fish blasted into space by these geysers, but the water samples will tell us what the conditions are like under the crust, and if there really is a possibility of life down there. Future robotic missions that aim to reach and traverse this ocean are still in the planning stages. Interestingly, while Europa is the most likely place to harbour life around Jupiter, it is not the only moon that probably has an underground liquid ocean layer. 3 of the 4 biggest moons of Jupiter, Europa, Callisto and Ganymede, all could have life under their surfaces. Callisto may have a water or ice layer up to 300 kilometers thick. Ganymede has at least one water ocean layer, but could also have several, all separated by sheets of ice. Ganymede is probably the second most promising moon of Jupiter, as the bottommost water layer could be touching rock. Water-rock contact would be an important factor for life to exist, as the rock provides minerals. Ganymede is already the biggest moon in the solar system, but data also suggests that its underground ocean could also be the largest. Ganymede will also be getting its own mission, this time from ESA, or the European Space Agency, and it will arrive about the same time as the Europa Clipper. You may be asking, why do these liquid oceans form under the surface of these moons? Surely being so far from the Sun means these moons should be frozen solid. Well, along with tidal forces from Jupiter, a predominant thought at the moment is that the moons generate heat through something called Rossby waves, also known as planetary waves. Rossby waves exist on Earth in its atmosphere and oceans and are caused by the inertia generated by the rotation of the planet. They are slow-moving kinetic waves, but over a whole planet or moon, they can store a huge amount of energy. This means the subsurface oceans on the moons could have a lot more energy than first thought, and may have currents and streams in them like in Earth's atmosphere and ocean. Beyond Jupiter, there are 3 more planets and their moons. Like Jupiter, the planets are very unlikely to contain life themselves. However, some of their moons also share the same characteristics with the moons of Jupiter. Particular moons of note are Rhea, the second largest moon of Saturn, Titania, the largest moon of Uranus, Oberon, the second largest moon of Uranus, and Triton, the largest moon of Neptune. The most exciting moon with these characteristics though is Enceladus, a moon of Saturn. It has extremely active geysers which spew 250 kilograms of minerals and water into space per second at over 2,000 kilometers per hour. It ejects so much material that it has formed a ring around Saturn called the E-ring. Cassini, a spacecraft that used to orbit Saturn, was able to pass through these water plumes and detected carbon, hydrogen, nitrogen, and oxygen, all key components of life. There is definitely heat being generated under the ice crust, which surprised Cassini scientists. There are also the tiger stripes of Enceladus, 4 massive canyon-like depressions 130 kilometers long and 500 meters deep that run alongside each other on Enceladus' surface, which are home to a lot of cryovolcanism and are warmer than they should be if they were heated only by sunlight. The evidence of hydrothermal activity, water, and essential chemicals means that this tiny moon could be the most likely place in the whole solar system to find life. Sadly, we are far from proving any of this. While there are some plans to return to Enceladus, these are a long way from launch, and the orbiters set to explore Jupiter's icy moons from above have not yet arrived. Actually exploring the oceans is still a very long way off. I can understand the problem though of getting a robot that deep into a moon, but it's a little disheartening to think we don't even have a timeline for such a mission. Beyond the planets and their moons, we have dwarf planets like Pluto, Eris, and Sedna. If they follow the patterns we see in the larger moons, they too could have liquid water oceans under their surface. But again, we are very far away from being able to prove that too. There are just two more curious places to look for life in the solar system. The first is Titan, the largest moon of Saturn. It is extremely cold and so is dismissed by some as uninhabitable. However, it is unusual from any other moon in the solar system in that it has a thick atmosphere with methane in it. In fact, the temperature is just right that liquid methane can form on the surface. The moon actually has a methane cycle similar to Earth's water cycle. There's evidence of seas, lakes, and rivers of methane and ethane on the surface of Titan. Other factors essential to life also exist there, including chemicals and minerals on the surface. Plus, the moon orbits mostly within Saturn's magnetic field, which means it is protected from solar and cosmic radiation. Theoretically, life forms could exist that replace water with liquid hydrocarbons. Such hypothetical creatures would take in H2 instead of O2, react it with acetylene instead of glucose, and produce methane instead of carbon dioxide. Excitingly, NASA is launching a robotic rotorcraft to Titan, set to blast off in 2028. If it flies above the methane lakes and spots something splashing around there, perhaps we'll have a definitive answer to the question of alien life sooner than we thought. The last place to look in the solar system for life is on comets. A long-standing theory is that life has propagated through the galaxy on the backs of comets, although it is quite an outside possibility. The Philae lander that visited the comet 67P Churyumov-Gerasimenko in 2014 was originally proposed to have life-detecting instrumentation on board. Sadly, this idea was laughed out of court, but as it turns out, the comet is rich with organic material, and there are clumps that resemble viral particles. These findings are difficult to explain with prebiotic chemistry. For now though, the concept of life on comets is heavily disputed, and so it will remain a remote possibility. Well, that's all we have time for today. I hope you've enjoyed listening to this podcast on the search for life in our solar system. If you like what you've heard, please feel free to follow us for more podcasts on other fascinating space topics. But for now, I'm Alex McColgan, and this has been Astrum. All the best, and see you next time.